Hello and welcome. In this video, we will learn how to remove unit productions to simplify the grammar. As we already know that we can simplify the grammar using three steps: by removing useless symbols, by removing epsilon productions, and by removing unit productions. So if you don't know how to remove useless symbol or remove the epsilon productions, then you can refer previous two videos where I have discussed with example that how we can remove the useless symbol and how we can remove the epsilon productions. In this particular video, we will be focusing on removing the unit productions from the grammar. So let us first understand what do we mean by unit production. So production of the form A gives B is called unit production, because when we fire this production A gives B, then we are not getting any useful string. Rather, we are just creating a pointer. We are moving from A to B, and whatever production we have for B, that will be derived from A. So unnecessarily we are creating a chain, or we are creating the length of a string derivation. So such productions we should remove to shorten the chain. For every CFG G with unit production, we can always find CFG G1 without unit production. So how to do that? So this method is only applicable when there is no cycle in the grammar. So first step, we have to expand unit production until it disappears. And to do so, first we have to add all non-unit productions to G1. Okay, so first we have to find out which are the non-unit productions that we have to copy as it is in the G1 grammar. And in step 2, we have to locate every pair of variables AI, AJ such that AI derives AJ by number of steps. Now there might be a direct derivation from AI to AJ, or we might be going from AI to some AM, AM to AN, AN to AK, and AK to AJ. So there could be a chain as well, but such pairs we need to find out. And once we do that, from pairs derived in step 2, we can construct a chain like A1 gives, A2 gives, AJ gives alpha, where AJ gives alpha is a unit production. So let us see how we can eliminate the unit production. So this is the example. And if we look at this, then in production S we have two unit production. S gives capital A, S gives capital B. And because to replace the A and B, we have to do additional work. First we are moving from S to A, and then we can replace A by either small a, capital A, or A. So instead of that, if we can remove those unit productions, then we don't have to traverse it two times. So let us first do a step 1. Add all non-unit productions to G1. So only first 4 productions of S we will adding into the G1. The productions of A and B do not have any unit production, so we will add them as it is. So this is the grammar G1 without unit production in step 1. In step 2, we have to look at every pair of unit production so that we can derive AI to AJ. So if we look at the production 1, we have a direct pair S gives A. And we have also a pair for S gives B. So these are the two pair of unit production. And in step 3, we have to remove this unit production. So we have to remove this S gives A and S gives B. And instead of that, we have to add the original productions of A and B. So if we add it into the grammar derived in step 1, then S gives ABA, BA, AA, AB will remain as it is. For S gives A, we have to replace the original productions of A, that is S gives small a, capital A, or B. We also have another pair SB. So for that we have to add all the productions of B now, starting with S. Because what we are doing is we are moving from S to A, and from A we have two productions. So rather it would be better if we can directly write it starting from S. So we have S gives B as well. So we will add two productions of B starting with S. So we don't have to traverse two times, and remaining productions we will add as it is. So this is the grammar without any unit production, and that you can verify. We do not have any production of the form A gives B. Let us try to understand all the concepts together now. So we have learned how to remove epsilon production. We have learned how to remove nullable variables. We have learned how to remove unit productions and so on. So to simplify the grammar, we have to perform 3 steps, right? So all those 3 we will apply now on this grammar. Till now, we were discussing only one step at a time. Now we have to simplify this grammar by applying all 3 steps. So this is the grammar. Let us first eliminate epsilon productions from the grammar. So there is one production of the form S gives epsilon. Right? So if we replace that S into the first production by epsilon, then we will be left with AB only. S is replaced by epsilon. Next, in second production, A gives AAS. So all two productions will remain as it is, plus A will be replaced by epsilon. So we will have one more production for A, that is A gives A capital A. In production of B also, we have three productions we will keep as it is, which is given in B. Apart from that, we have to add some more additional productions by setting S as an epsilon. If we set first S as an epsilon, then we will get the production B gives BS. If we set second S as an epsilon, then we will get B gives SB. And if we set both S as an epsilon, then we will get B gives B. So these three additional productions will be added into B, and all the epsilon productions are removed. So in short, in just one step, we have removed all the epsilon productions. In step 2, we have to eliminate unit production. So do we have any unit production here? Do we have any production of the form A gives B? In production S, we do not have. For production A, we do not have. In production of B, we have that. B gives A is there. So to eliminate that unit production, we have to replace that capital A by all the productions, original productions of capital A. So B gives A is unit production. So S will remain as it is. Capital A will remain as it is. In capital B, except B gives A, all productions we have to copy as it is. And instead of A, we have to write down original three productions of A. That is A gives AAS or AA or A. So this is how we can eliminate the unit production. And the third step is eliminate the useless symbol. So let us see, do we have any useless symbol or not? So all symbols are reachable from S. We can see that. From S we can go to A, from S we can go to B, and there are only two such variables, A and B. So both are reachable from S. So whatever grammar is shown in step 2 will be the final simplified grammar. So this is how we can simplify the grammar by performing 3 steps. Let us try one more example. We have to simplify this grammar. So do we have any epsilon production? Yes, we have C gives epsilon is the epsilon production. Then we have production called A gives C. So ultimately A is also nullable. We have B gives A. So ultimately B is also nullable. And we have S gives double B. So S will also be nullable. Right? So when we have to eliminate the production, so we direct epsilon production is only one, but we have lots of unit production, or we can say we can derive the epsilon through the chain. So all those we have to replace by the epsilon. So A, B, C, S all are nullable. So now one by one we will replace it by epsilon, and we see that how many other productions we can produce. So all three productions of S will be kept as it is. In first production, if we set A as a null, then we will get 0, 0. In second production of S, if we set B as a null, then we will get 1, 1. And in third production of S, if I set 1B as an epsilon, then I will get only B. And if I set both the B as an epsilon, then I will get the epsilon. Right? But epsilon productions we have to remove anyway at the end of this procedure. So we are not adding it into that. Next is A gives C. So there is no scope of doing anything. In B gives S oblique A also there is no scope. And C gives S will be the only production. Epsilon productions we have to remove. So this grammar represents epsilon free grammar. In step 2, we will eliminate the unit productions. So how many unit productions we have? One is a S gives B, A gives C, B gives S, B gives A, C gives S. So if we look at the grammar carefully, then there is a chain. S gives B, B derives A derives C, and C derives S. That means all productions will be having same to same right hand side. So I can write the production of the form like S gives 0, A 0, 1B1, double B, double 0, double 1. Fine. And we have to remove unit production. So B we are removing. So all the productions of B we have to copy here, but B do not have any production which is not unit. There are 2 productions of B, but both are unit productions. So we do not have to add here. For A derives C, now we know that it's a cycle. A derives C and C derives S. So all the productions of S we have to copy into A. So A will also have the same productions. For B, we know that B derives S. So all the productions of S we have to replace here as well. And similarly, C derives S. So all the productions of S we have to copy into C as well. So this is the set of productions without unit production. In step 3, we will eliminate the useless symbols. So from start symbol, if we look at the productions of S, then from S we can go to A and we can go to B. From A we can only go to A and B. From B we can only go to A and B. But from C there is no way. We cannot go to C from S or A or B, and hence C is not reachable and we can directly remove it from the final grammar. So these 3 productions are the simplified grammar. Let us talk one more example. We need to simplify this. First step is eliminate epsilon productions, but we do not have any epsilon productions. So this is already simplified according to epsilon production removal. Second step is eliminate unit productions. So we do have many unit productions. B gives C, C gives D, D gives E, and E gives A. So to derive A from B, we have to traverse a long chain, B to C, C to D, D to E, E to A, and so on. So it would be nice if we can directly write B gives A, right? So that we can derive the A in just one step. Fine. So B gives C, C gives D, D gives E, and we know that E gives A. So if we remove this unit production, then our production set would look like S gives AB, there is no unit production. In A gives B also there is no unit production. In B gives C, there is a unit production. So we have to replace that C by D. Again, B gives D would be unit production. So we have to replace that D by capital E. But again, B gives capital E would be unit production. So we have to replace that capital E by small a. So finally, we will have the production for B like B gives A oblique B. B is already there. For C also, C gives D is a unit production. So remove D. If we replace D by E, again it is a unit production. So remove E and replace E by A. So we have the production of the form C gives A. Same for D and same for E. So this is the set of productions without any unit production. And finally, we have to eliminate useless symbols. So we have to verify whether all the symbols are reachable from start state or not. So from S we can reach to A. From A we can go to just a small a. We cannot go to any other state. So B, C, D and E are not reachable from start state. And hence in simplified grammar we can remove all those symbols, and our final equivalent production simplified grammar for the given input grammar would be just 2 production. S gives AB and A gives A. So this is how we can simplify any given grammar by following 3 steps. Again I repeat, for individual step I have prepared individual videos, and later in this video itself I have given 3 examples where I am applying all 3 steps together and simplifying the entire grammar. Thank you. That's it for today folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.